Let's have a look now at part 2, second harmonic with different tensions. It says, in this experiment, you will measure the frequency of the second harmonic in a stretched string with different tensions and calculate the wave velocities found from the measured frequency and the wavelength. You will then plot a graph of velocity against tension and work out what manipulation or change is needed to one of the variables to produce a straight line graph. Once you have a straight line graph, you will need to write a full equation of the graph. This means you will need to find the gradient of the graph. You will then work out what the gradient represents and compare this value to the other measurements that you have taken. So we're going to explore the way in which this wave moves through this string. So looking at the aim, what are we trying to do? Well, we're trying to find the relationship between those two variables. We're graphing velocity against tension to see what values we get from that and what that means. So, as far as the method is concerned, it says measure the mass and the length of the string to determine the linear density. Well, you've got those values from the previous exercise. So they go into your table. The mass of the string, kilograms, the length of the string in meters as before. The linear density remains the same. The length of the vibrating length of the string remains the same. It's 110 centimetres, in other words 1.1 metres. Now, the hanging mass. This is the one that we're changing. We're changing the tension. So at the moment, I've got 50 grams suspended on the end of that string. So that's the first figure that needs to go in the table there where it says hanging mass in brackets G for grams. So we put that in grams. Then from that figure of grams, you can work out the tension, the force. It's the force of gravity acting down on that mass. So convert 50 grams to kilograms, of course, by dividing through by 1,000, and then multiply that by 9.8, and that will give you the tension. And what we will be doing, we'll be adding 50 grams each time to change the tension. Or we'll be adjusting the frequency to maintain the second harmonic in this string. So at the moment, I've got the frequency set at 5, and I'll start the vibrator. And that doesn't look anything like the first harmonic. So I will increase the frequency. And what I really want is the second harmonic. Now that looks as if I'm getting very close to it. Maybe it is too low. I'll try at 21, 22. Now it's becoming unstable, so I'll go back down. That looks fairly stable. No, it doesn't. I'll try 20 again. So that's stable at 19 Hertz. So that frequency then goes into your table there as the first measured frequency from the data logger. So now I'm going to add another 50 grams to the mass. As you can see, it's no longer in the second harmonic, so what I'm going to do is adjust the frequency. So that gives me a frequency of 26, which looks like a nice second harmonic. I'll now put on another 50 grams and adjust the frequency. So at the moment that says 32, that looks fairly good second harmonic. 32, so that's 32, so that's the next value to write down. Again, I'll add another 50 grams and you can work out the tension that's in the string there. Again, it's the mass in kilograms, so that mass now is 200 grams. So 200 divided by 1,000 multiplied by 9.8, that will give you the tension, and I will adjust the frequency. So that frequency is 36, and that looks like a nice second harmonic. Again, I'll put on another 50 grams, so that's 250 grams. You'll be able to work out, write the mass in, and then work out the force. And I'll adjust the frequency again. A bit too high. So that's 40 hertz. So that's the next value that goes in here in measured frequency. So that's the value there that goes into the table.
Now stop the video and calculate the velocity for each one of the tensions. After recording all your results, you should have a table that looks something like this. Now the next step, of course, is to draw the graph with tension as the x-axis. Instead of doing this on paper, a far better way is to use Excel, a spreadsheet. And this is what I've got here. What I've got already is the tension written here. I have included the frequency here because I'm going to use the frequency to work out the velocity. So I'm going to type in here the formula for the velocity. So that's equals to, now the length was 1.1 meters times the frequency. Okay, wavelength times frequency, and then I click on here and pull this down, and that gives me all the values for the velocity. Now to create the graph of tension versus velocity. So first of all, of course, I'll select the two columns. So select the first one, hold down the control key, select the second one, go up to insert, go across here to charts, click that, click the first one, and that gives me the graph. Now I do need to put in a title, so I'm going to click on here and click here chart title. So I'll type that in. Okay, so that was a quick type, and I also want to type in the titles and the units. So I click on the plus sign again and go across here to axes, titles, click that and type those in. So now you can see we've got the labels and the units for both velocity and tension. Now when I have a look at that graph, does it look like a straight line or does it look like a curve? To me it looks a bit like a curve. So maybe going back down here to 0. So it looks a little bit like an exponential. Now there's the question of the manipulated variable. What we know, what we've learned so far, or what we've seen so far, is that the velocity is equal to the square root of the tension divided by the linear density. Now, if we square both sides, we get that the velocity squared is equal to the tension divided by the linear density. Again, if we divide by the tension, we get v squared, the velocity squared, over the tension is equal to 1 over the linear density. What we've done so far is draw a graph of the velocity versus the tension. If we draw a graph of the velocity squared against the tension, what we should expect is a straight line. The gradient of that straight line, the rise over the run, should be 1 over the linear density. Now, is that true? Well, what we can do is just test out the dimensions. Let's have a look at those dimensions, or let's look at it another way. If we get the reciprocal of this, we get the linear density is equal to the tension divided by the velocity squared. The tension is, of course, a force, so we can think of that as the mass times the acceleration divided by. Now here we've got meters per second. Let's break that down a little. Mass is is m, capital M, its dimensions. Acceleration is length divided by time, and this time capital T here is the dimension for time, and here we've got meters per second, and that is squared. So we've got length squared, which is that squared, divided by second squared, which puts time squared up here. So we've got some cancellations that we can do there, which gives us mass divided by length, which of course is the units or the dimensions for linear density, mass per unit length. So what we should do at this stage is graph velocity against tension. So our manipulated variable is the velocity squared. So back here at our Excel spreadsheet, what we're going to do is change the size of this so we can fit on another graph. And furthermore, I will create a second column here, velocity squared. I'll first of all type in the title. I'll include the units, of course. when I've got this meters squared per second squared, I might like to put in the superscripts here. So I'll select the 2 here, go up to Home, and go across here to the font, and down here and select superscript. And I'll do the same for the other one. In order to create the velocity squared, of course, I'm just going to put in a formula, beginning, of course, with equals. And the cell that I'm going to square is this one here. So I'll click here, raise to the power of 2, press enter, and fill down. So click here, grab hold of the little corner down here and pull that down, and that gives me values then for the velocity squared. What I now need to do is create a graph. So again, I will select this column, tension for the x-axis, hold down the control key, select this for the velocity squared and the y-axis, go up here to insert, across here to this particular graph and this particular scatter, and that looks much more like a straight line. And what I'm going to do is move this graph down here where I've got a little bit of room, and then move the screen down a bit so that I've got that in focus. Again, what I've got to do is put in the chart title and the units and labels. So in order to do that, again, I click on the plus key and select axis titles and chart title and type those in. Now that I've got the labels and the units, labels, units, what I need to do is put in the line of best fit. To ensure that I can get the line of best fit, what I need to do is click on this, have it selected so that I get the plus sign here. Clicking on this plus sign, I go down here to trend line. And this, of course, is what the Americans call the line of best fit. So I click on that and go to linear, and down here to more options. So linear there is selected, and right down the bottom here I select intercept to 0, so it will pass or seem to pass through 0. Then I'll click display the equation on the chart and click close, and there we have the equation there. So if we have a look at this value here, this is in the form of y is equal to mx, and as we've discussed earlier, the value here for the gradient ought to be the same as 1 over the linear density. So I'll just do a quick calculation of that down here. I'll say this is equal to 1 divided by 800.77, press enter, and I get a value of 1.239 by 10 to the power of -3. Let's compare that with the previously calculated value of the linear density. Create your own spreadsheet graphs and put those into your workbook. You should be able to do screen capture of your spreadsheets. You should be able now to answer all of these questions, including number 5 here. And as far as your conclusion is concerned, you shouldn't have to write more than, say, 2 sentences for the first one, and the other ones there should be quite straightforward.